A very reasonable question would be, how do you sit comfortably with that horseshoe up your ass? And all I can say is a combination of cheeseburgers and you get used to it. Hello Internet, my name is Quentin and this is Blondihacks. As regular viewers know, I recently upgraded my milling machine to the PM-728 and it's a fantastic machine. As I said in the video where I reviewed it, it's very, very solid in all the ways that matter. You know, the ways are really nice, the lead screws are awesome, spindle bearings, drive system, all first rate. Really, really nice machine. Where it falls down a little bit is all the little quality of life things, the little niggling details that nag at you every time you use the machine. And those are the things I'm going to take care of in this video. It's kind of a collage of all the little modifications and improvements that I've been making over the few months that I've been using that machine. So I hope you'll find something interesting here, whether you're a 728 owner or an owner of any other small milling machine. All right, let's go. I started with the biggest no-brainer of small milling machines, and that's to install a Priest Tools power head lifter. Greg makes these kits for all manner of small milling machines, not just Precision Matthews. He's got kits for Grizzly and lots of other machines, so chances are he's got one for you, and let me tell you, once you've lived with a power head lifter, you will never go back to cranking that thing up and down. And if you've got a knee mill, there are companies that make knee mill motors as well. Once again, once you've lived with it, you will never go back, especially on a machine like the PM-728, where the head is actually quite heavy. So the crank you can see there is quite big and the gearing is low to give you some mechanical advantage, but that means you do a lot of cranking and your shoulder is going to get sore. I'm zipping through this because I've already done an entire video on installing one of these kits, so if you want the details here, I'll link to that video below. Sometimes it's the little things. This armored cable drags on the edge of the aluminum shield for the DRO and makes a rattling noise when the head moves up and down. This is an easy fix, courtesy of gaffer tape. Not duct tape, gaffer tape. The good stuff, or the consumer version of it, Gorilla Tape. While we're talking quick wins, there's these two random threaded holes in the front of the casting. No doubt they are there for some other machine that uses this same base casting. These castings are made by foundries that then sell them to the Chinese machine tool companies that then use them for various machine tools that they sell. And so they often have random holes in them like this that are used for some other purpose that does not apply to this machine. They were all full of paint, but I was able to determine what thread they actually were and chase the threads, and then I just put some little set screws in there to keep chips and oil from accumulating in there and piling up inside the base forever. That's all fine and good, but let's get to the real reason we're here. When I did a review of this machine after first receiving it, you might recall that I did some heavy test cuts to see what this machine was capable of. And during those test cuts, I noticed what seemed like a pretty substantial issue. And that's that the quill apparently pulled itself down 3 thousandths during that cut. I had set that depth of cut to 50 thousandths with the quill, and as you can see, by the end of the cut, it was showing 53 thousandths. It seems as though the quill lock is insufficient or something else is wrong such that the cutter is actually being pulled down into the work during the cut. Now, after several months of living with this machine, I've determined that that's not actually what's happening. That much of a cutter movement would be showing up as taper in the parts, and this machine's cutting very parallel, so it isn't actually moving the cutter. There's something else wrong. Well, then one day, I noticed this. Give it a little yank on the mounting bracket here, and look how much flex there is in that. You can easily pull it out of whack by a good 20 thousandths. And after you pull on it, it doesn't go back to where it was. It goes back to some random place that's 2 or 3 thousandths off from where it was. So this appears to be the actual problem. When the quill and the head of the machine load up under cutting forces, that bracket flexes and doesn't go back to where it was when the cut is done. So this chintzy little sheet metal bracket, I think, is the actual problem for this apparent 3 thousandths of movement on the quill DRO. The cutter is not actually moving, just the DRO scale is moving relative to the quill. This seems like really good news because, hey, we can fix a chintzy bracket. Now, let's not stop there though, because if you watched my review of this machine, then you may recall that there was a number of issues with this quill DRO. The other big one was viewing angle on the LCD is quite poor. You can't read the numbers very well unless you're crouched down and looking directly at it. And this thing has an auto shut-off, as many of them do, but the timer on it is very, very short. It actually auto shuts off during a long cut, which is really annoying. In an optimistic effort to solve all of these problems all at once, I spent some quality time on AliExpress and decided to see if I could find a quill DRO that would fit in the space occupied by the current one, but did not have all of these niggling issues. This is the one that I landed on. It's by Shahe or Shahe. I'm not sure how to pronounce that, but I'll link to this one below. This is one of the more common brands of these digital calipers and scales, so these are not hard to find. I chose this one primarily because it seemed like it had the features that I wanted in the description, but more importantly, the description on AliExpress had mechanical drawings in it, so I was confident it was going to fit. That's very difficult information to get. For something like this, when you're buying it on AliExpress, getting the exact dimensions is often difficult. But this one had the drawings, so I was confident it was going to work. Quick test here, and it does seem to work. And importantly, the viewing angle on the LCD is excellent, as you can see. All different vertical angles, it still seems to be very readable. That's a really good sign. We're off to a good start. Now I'll see about mounting this thing inside the head. I'm not sure exactly what that's going to require, but there's only one way to find out. Fortunately, this thing is quite easy to get out of there. It's just held in place on the bottom by those cap screws that attach it to the chintzy bracket, and then there's a single cap screw in the casting that attaches the body of the DRO to the head. Let's do a quick test fit of the new one to see if it's likely to work. Seems like it will. When I was shopping for these, the main dimensions I was concerned about were the width and height of the head unit of the DRO, because it needs to fit in the casting, but also it needs to fit in the hole in the sheet metal, or at least be close. In this case, the height is exactly the same, and the new unit is ever so slightly narrower, so it will fit in the hole in the sheet metal. That's a nice feature. I won't have to modify anything there. I might even be able to reuse this factory bracket, actually, because there's mounting holes in very similar places on the back of the new unit. Holding it up here, yes indeed, actually, those slots will line up. The mounting hardware on the new unit is M3 instead of M4, so I'll have to use different bolts, but otherwise, I think it's going to work. I'm going to need to cut the scale down to length. You can tell on the original, that is how the factory is making them. They are cutting down a standard 100mm scale to length and drilling holes in it for mounting. I did a quick hardness check on the scale with a file to see if I can cut it. I'm not sure if this is hardened steel or maybe stainless. The file is in fact cutting it, so this is probably stainless. That's good news. If it was hardened, then this whole job was going to get a lot harder. Look, these are the jokes, people. I gave it a shot on the bandsaw, and this cut it just fine. That's good news. That suggests this might be 303 stainless, something fairly easy to machine. If this is 316 or 416, then it would be very, very difficult and we would be in trouble. It's not even getting warm though, so easy cutting, and I can easily chamfer that edge with a file. Pro tip, if you take one of these apart, there's a little leaf spring that just fell out that holds the tension against the scale inside. That leaf spring is retained with a pin in a hole. There's really nothing else holding it. So you have to very carefully set it in there and then use the scale to essentially hold it in place. Something to watch for if you take one of these apart. As I said earlier, in an amazing stroke of luck, the factory bracket actually fits. The holes line up and everything. This new unit uses smaller hardware, so I couldn't use the original M4 bolts. I didn't have any M3 button head bolts, which would have been a better choice here, but these will work. Time for another test fit. I want to get this in and see what my options are going to be for mounting the bottom. Looks like I can't use the clamping style brackets as is that came with the new DRO. I'm going to have to do something else for mounting the bottom, similar to what the factory did. They just drilled holes in the scale because the scale lines up essentially flush with the bracket. They had some spacer washers underneath it. Well, in amazing stroke of luck number 2, if I set the new unit in here with no bracket on the bottom, in fact, the scale lands perfectly flush on the surface of that bracket, so no spacer washers or anything required. Much like the factory bracket, I can simply drill holes in that scale to mount it, and I won't need any spacers or trickery at all. This is working out better than I could have possibly hoped. This also gives me the chance to clamp the bottom of the scale to the bracket and give it a little test drive here to see if this is going to work. Stroke of luck number 3, the battery door even still opens. I was concerned about that because this is a slide out type instead of a screw in from the front type, but that works just fine, as does the quill when mounted in this position. It's reading correctly, and the scale is long enough there. I cut it to a good length, and everything seems to be working great. So I think this is just crazy enough to work. As you can see, this quill upgrade has not done anything to fix the rigidity problem of the chintzy bracket. And in case you were wondering, no, it's not the quill. As you can see here, I can shake the whole machine by the quill and nothing moves, but just touch that bracket and the numbers go crazy. It is definitely the bracket, not the quill that's moving. Time to get that bracket off and have a look at what we can do about it. I had low expectations for the quill attachment point, but actually it's quite good. There's a nice machined flat spot with nicely threaded holes, so there's nothing really at issue there. We can definitely reuse that. Taking a closer look at the bracket, it's steel, but it is very thin sheet metal, and it's pretty clear why it's too flimsy. Now, probably you could weld a piece of round bar in there to stiffen it up and fix this problem in 10 seconds, but I thought it would be fun to machine an entirely new bracket out of solid aluminum, so that's what I'm going to do. The stockpile coughed up this lovely piece of bar stock that's just about perfect. It's just a little bit bigger in every dimension than what I need. I love it when that happens. I'm going to start by squaring this up. I'm going to do this the traditional way, involving rolling the part around, putting reference surfaces against the fixed jaw, etc. I'm not going to go into detail here. I have an entire video on the traditional method of squaring up stock. If you're interested, check out my Mill Skills playlist. There is another common way to do this, which I sometimes call the CNC way because it's the way that CNC machines tend to do it, which is to hold the piece just by the bottom edge, which gives you almost complete access to the top 5 sides of the part. Then you face the top and side mill the 4 sides around that top. Now that doesn't work as well on small machines because when side milling you get more deflection because small machines are not as rigid, so you aren't going to get as much squareness out of the part doing that, and you tend to be left with a big heavy cut that you have to take on the far side of the part at the end, which again small machines aren't as good at. So for squaring up stock on smaller machines, I find the traditional method shown here does actually work better. Whatever method you use, there will be a moment in the process where a particular axis needs to be brought to dimension as well as being squared up at the same time. For that, rather than measuring anything, I'm simply scribing the dimension off of the original part. This is plenty of accuracy for this type of thing. I'm just going to scribe a line and mill down to that line by eye. No need to be more accurate than that with a simple bracket like this. When it comes to squaring up stock, even with the traditional method, however, my one conceit to laziness is that I will always side mill the ends, rather than the officially correct technical way of squaring up stock, which is to stand the piece on end at this point, indicate the side in perfectly vertical with an indicator, because of course it's sitting on an unmachined surface, then machine the ends with the end of the end mill, because doing it this way, once again, there's always going to be deflection when you're side milling, so these end pieces will not be quite as square as you could achieve if you did them the traditional way. But again, who's got time for that? Since the front and back of the bracket are different heights, I thought I would mark a jaunty angle on my one-piece bracket, and this will make it look nice and also help give access to the screws that are going to be bolting this thing to their respective components. Here's my favorite trick for medium precision, if you will, milling of an angle. Scribe the line on the part, place a parallel on top of the vice jaw, line the line up with the parallel, clamp it down, remove the parallel, and presto, you can mill down to that line without hitting the vice jaws. While I'm making chips, let's talk about auto shutoff. I was not able to find a quill, DRO, digital scale, linear scale, digital caliper, anything that doesn't say specifically that it is not auto shutoff. Those don't seem to exist. This one did say in the Alibaba listing that it is configurably auto shutoff. However, it came with no instructions and I cannot figure out how to disable the auto shutoff. So in theory you can. However, on the plus side, at least the auto shutoff on this one is 5 minutes instead of 1 minute, and it wakes itself up automatically when the scale moves, which the factory PM1 does not do. So those two things still make it a huge upgrade in the auto shutoff department. Next, I need to hollow out the center to form the actual bracket. My design here is that it's going to be a U-shaped bracket like the original, but it's going to have solid angled side ribs along the sides to reinforce it and make it rigid. So for that, I'm just going to mill out the center here and form a pocket to create the shape all at once. I'm touching off on the low side of the angle because I need to know exactly how far to go downwards in order to leave the thickness on the bottom that I want. I'm going to start this pocket by plunge milling down to final depth at the highest point, and then I'll side mill out the pocket from here. At least that was my plan. This turned out to be a little bit too much depth for side milling all at once on my little mill, so I ended up bringing the cutter back up a little bit, and I did my side milling in a couple of passes, working my way down. I milled out a channel down the center first of all, and then worked outward from there, milling the kind of rectangular shape of the pocket again in a series of passes, working my way down. And I'm milling clockwise around the part so that I am conventional milling all the way around, never climb milling. The way this pocket is dimensioned is pretty straightforward. I had edge found to find the center of the part, then I worked out to plus and minus extents for the size of a pocket that would leave a 1/4 inch wall thickness all the way around, and then of course accounting for the radius of the cutter that I'm using. And that gives me the positive and negative numbers to work to on the DRO for both X and Y. I used a fairly large diameter cutter for this first pass for rigidity and efficiency in that cut, but the corner radii left by that are too large of a diameter. They're going to interfere with the clamping hardware. So to finish up, I came in with a smaller diameter end mill that has a nice long reach that allows me to get in there and side mill into the corners to shrink the radii of each corner. I'm also milling the bottom a little bit. I left the depth a few thousandths shy of final depth so that I can do a cleanup pass with this smaller end mill at the same time. So once I'd sharpened up those corners, then I milled the bottom flat, and Bob's your uncle. There's the pocket. On to the quill mount. For this, I'm measuring the factory bolt pattern, the size of each and their spacing, which gives me the positions of the clearance holes that need to go in my new bracket. And these, of course, I centered up once again with the edge finder, and this is easy peasy lemon squeezy, but only with consent. I did have to find some longer M4 bolts for this because, of course, my new bracket is quite a bit thicker than the sheet metal one was, so the short little factory bolts are not going to be long enough. The factory bracket had access holes drilled in the front in order to get to these bolts, but honestly, it didn't really seem necessary. With a ball nose Allen key, it was not very difficult to get in there. And then, of course, the short end for tightening it, so I didn't bother putting the clearance holes in the end. Quick seat of the pants rigidity test, and I would say that passes with flying colors. I can shake the entire mill by that little bracket, so I think it's safe to say it is very rigidly mounted now. And once again, amazingly fortunately, the new Quill DRO scale matches exactly with the surface of that bracket with no spacer washers underneath like the factory one had. Really incredibly lucky. I thought I might be able to use the little clip that came with the new DRO for mounting, but it's actually wider than the bracket I just made, so I would have had to plan ahead better for that. That's okay, I'll drill it through and bolt it the same way that the factory one was mounted. Now the real test, though. Have I actually solved the rigidity issue with the bracket? I can clamp that on there, give it a little test, and oh yes, look at that. If I yank on it hard enough, I can get 1/1000th of movement out of it, but importantly, it always goes back to 0 when I let go. So we've eliminated almost all of the movement, and the rigidity is orders of magnitude better. Really, really an excellent improvement. One more quick test drive before I commit to attaching the scale to the bracket. Everything seems good, so I think I'm ready to go. Let's go ahead and drill the holes to mount the bottom end of it. One bolt would probably be enough to hold the bottom of that scale in place, but I figured I might as well use the factory 2-bolt pattern because then I can put the old DRO back on if I ever need to. I set this up for drilling, get it centered up with the edge finder. Now, when I line up where the hole needs to go, it lands right on that shoulder where the plastic insert is. And that means the drill is going to tend to wander. I decided I'd better come in here and make a flat spot first to keep the drill on target. You might be asking, well, why didn't you just drill it from the other side then? And, well, because shut up, that's why. Here's where my luck finally ran out on this upgrade. I was cautious about face milling and drilling this, being that it is stainless. I thought it was probably 303 because of how easily it cut on the bandsaw. But no, it is definitely not 303. Trying to plunge mill a flat spot trashed that end mill immediately. I figured I had probably work hardened the material at this point, but I did get my flat spot, so I thought, okay, come in with the center drill and the drill and try to drill this through. But the center drill worked okay, however the main drill, no good. It's not getting hot, but it is definitely rubbing, not cutting, and it's almost certain that I have now work hardened the stainless in that hole. I took another shot at it with a cheap drill that I don't care about, but that is sharp, to see if I could just kind of muscle my way through the work hardened top surface and finish this, but nope, I just trashed a second drill trying that. Well, that's a problem for a future Quinn. Let's try the other side while I'm set up. Being a lot more careful now to get in and get out, which is the secret to drilling stainless. Don't let the drill rub. But even being very careful to not let anything rub, the drill was not cutting at all. Again, the center drill did okay, but the main drill just instantly started work hardening and instantly burned the end off the drill. I was really shocked how quickly this stuff work hardened. So I'm thinking it's probably 416 stainless, something really ornery like that. Now I'm in trouble. I've got two partially drilled holes with thoroughly work hardened bottoms in them. What am I gonna do? I dug through my drill bins and I found this bad boy. This is a solid carbide drill in exactly the right size. Now, to be clear, this is literally the only carbide drill I own, and I didn't even know I owned it. I found it in the back of a drawer. Someone must have sent it to me at some point, and it was the exact right size. A very reasonable question would be, how do you sit comfortably with that horseshoe up your ass? And all I can say is a combination of cheeseburgers, and you get used to it. But look at that carbide go. Just chewing through hardened stainless like it's nothing. Carbide is really amazing. So thank you, Cobra Carbide, for making this drill that appeared in the back of my tooling drawer somehow, waiting for its moment to be the hero. Those holes are not going to win any beauty contests because of all of the garbage that I did leading up to switching to carbide, but I got it done in the end, and that's what matters. You probably noticed that those drills were wandering despite all my efforts to prevent that, so I ended up transfer punching these holes onto the final bracket because I know they didn't end up in the exact places where they were supposed to. So if I just measure them and drill out the bracket, they're not going to be in the right place. So transfer punching for the win, and the factory DRO may not bolt on correctly depending on how big the clearance holes are. But the new DRO bolts on perfectly, and despite the holes being slightly cattywampus, we will say that's all that matters. Moment of truth though, did I actually solve the problem? Let's do some heavy milling cuts and find out. Boy, did I ever. Look at that. That's a 40 thou depth of cut, and that quill DRO has not moved even a tenth. That is beautiful. Go back the other way, doing a 60 thou depth of cut, and again, zero movement on that quill DRO. Double Imperial fist pump of victory. That is huge. This is the #1 issue that I had with this machine, and it's a huge relief to have it fixed. I can finally start trusting the quill DRO. Next, I'm going to focus on the way cover. This factory piece of neoprene acts as both column and bed way cover. It works okay, but on the bed, as you can see, it doesn't keep out all the chips. I'd like something with a little better coverage than that. On my previous mill, I did a thin piece of leather as a bedway cover, which worked really well, so I'm going to do the same thing. Conveniently, the base of the column actually has bolts on it already, which look like they could have been for mounting a column way cover, but I think actually they're supposed to be stop bolts because they have little adjuster nuts on them. However, the stopping distance of the bed is set by the DRO on the back anyway, so those bolts aren't doing anything. The leather that I'm using is 60 thou thick. However, leather thickness is measured in ounces. It's kind of an old-timey measurement, so this maps to 3 to 4 ounce leather if you're looking for something similar. I found this bracket in my scrap bin that I'm going to use. It's already got some slots in it that needed widening. Punch a couple of holes in the leather and I should be ready to go. I'm mounting on the back of the table using the factory mounting bolts where the neoprene was. Then at the base of the column, I've got my new aluminum angle bracket. Now that bracket could just be a flat piece. You could mount both the neoprene and the leather on the same locations, but I happen to have an L bracket, so I just used that because it seemed a little bit cleaner. Next, I'm going to cut the neoprene shorter because if it's just covering the column, it doesn't need to be as long. And this way it won't bunch up as much when the head is down very low. When doing way covers, you want to make sure that the way covers are not compromising table travel or head travel on the machine. That can really cost you in setups. The acid test of this, of course, is to run the table all the way back and the head down as low as it'll go, more or less. And there's nothing interfering with travel. The travel limit on the back is still the DRO scale, which is good. I haven't made anything worse. Well, that is all the time I have. I'm sure there will be more mods made to this machine, and I'll keep you posted when I do another batch. But these few changes here have made a huge difference in quality of life for the machine, especially that quill mount. So if you have this machine, strongly recommend you make that change, if nothing else. Well, thank you very much for watching, and thanks to my patrons especially, who make all of this content possible every single week. You guys mean the world to me, and I will see you next time.